In this presentation, let us understand the different types of functions in Python and their role in program and application development. In Python, we have two functions, namely pure functions and modifiers. We try to learn or adapt these two functions in simple application development or program development with the strategy called prototype and patch and the planning. Functions are classified as pure functions and modifiers. This classification is based on the state change made by the functions. Pure functions are the functions which takes objects as a parameter and perform some computation without modifying the passed objects or outputting something. Let us take up one example. We define a class called point with initial values x and y equal to 0. Then we define a function called distance which takes two parameters which are objects r and s. What this function does is function takes the midpoint of these 2 points. R is a point, S is also a point. We are going to create one more object of point and then we calculate the midpoint of R and X, and then we return this new point which is a midpoint of these 2 parameters. If you observe this function, we don't find any statement modifying the object parameters R and S. We are just accessing the properties of R and S, and we are assigning those new parameters to the new object, thereby we return the new objects. And this function is a pure function because it doesn't modify R and S, the object parameters of the function distance. This is the main program. We create 2 points P and Q and we initialize the values, and then we make a call to a function distance, and this function is a pure function which doesn't modify P and Q, I mean R and S, because R and S becomes the alias to P and Q, and this function returns a new point which is a midpoint of P and Q. Modifier is a function which receive objects as parameters and perform computation by modifying these parameters, I mean object parameters. Let us understand by taking a simple example. We'll take up the same class point and we write this function called translate point. What is this function does? This function reads the displacement for the existing point so that we identify the new coordinates. So this function ultimately takes one parameter, there is a point parameter, then this function reads 2 values, displacement values, displacement towards x direction and dy is to the y, and then we add this displacement to the object parameter p of x is equal to p of x dx will change the object state. Similarly, the next statement change the object state. Ultimately, this function changes the state of the objects. That's why this translate point, trans point, is a modifier which modifies the object parameter. This is the main program. We create a point, we initialize values for x and y as 2, and then we make a call to this modifier. This modifier function modifies the values of c dot x and c dot y, and ultimately we receive new values. In some programming languages we don't find modifiers. Only few languages provide the modifiers, and Python provides both the flavors. We can write a pure function as well as we can write modifier, and the studies show that programs that use pure functions are more faster and less error prone than programs that use modifier, because modifiers alter the object state and it is little tricky and tedious to track the object changes. At the same time, sometimes modifiers are convenient to use, and also we can say that pure functional programs tend to be less efficient in some of the situations or scenarios. In general, it is recommended that the programmer should use the pure functions whenever it is reasonable, and also have to write the modifiers only if there is a compelling advantage. And the use of both pure and modifiers to solve a programming problem or a real world problem is called functional programming. And what is the philosophy of functional programming approach? In functional programming, the complex problem is decomposed into smaller problems, and these smaller problems are modeled as either pure functions or modifiers, so that we design the solution to the whole problem. Now let us understand the role of functions in application development. As we know, any application development for a given real world problem is a complex problem. Let us take up the institution automation system. It is a complex problem. The problem has got so many sub problems. Similarly, the employee leave management or human resource management problem. These real world problems have number of sub problems. We need to use the functions, I mean pure and modifier, suitably to demonstrate or to design the application development through an approach called prototype and patch. What is this prototype and patch? Prototype patch is a process of application development wherein we tackle this complex problem by starting with the simple prototype of solution, and then incrementally we enhance the prototype by dealing with the complications or constraints or even errors. As an illustration for the prototype and patch, the application development strategy, we will define a simple class called time, which represents the time of day. And the definition of this class look like this: class time, and we define three attributes. One attribute for the hour, one more is for the minute and second. Now let us create the time object, and then we assign attribute values to the attributes. We have created an object called time. Then we assign values 11, 59 and 30 for hour, minute and second attributes respectively. Now we define a simple prototype function to add two time objects. The time object represent time of day. Let us say we have two objects representing two different times in a day. How do we add? So we have a very simple prototype, a basic prototype, which adds two time objects. The function definition goes like this. Add underscore time is a function name to add two time objects. These are the parameters t1 and t2 time objects. We create a new time object and then we assign hour of first and hour of second to the new time object, hour of the new time object. Similarly, we do it for the minutes and we add seconds, and finally we return sum. This function will create a new time object and also it initializes, it attributes hour, minute and second based on the values of the hour, minute, seconds of t1 and t2, and finally it returns the new time object called sum. Note that this add time is a pure function because it doesn't modify the object parameters t1 and t2. To test this function, we create two time objects. One is start to represent start time of a movie, and second is the duration of the movie. What's the duration? For example, movie goes for 2.5 hours, then 2 hours 30 minutes and 0 seconds, and ultimately by adding start and duration we'll get the movie end time or finish time. So let us figure out when the movie will be done. We first create a start time object. We initialize the movie starting time by assigning the values. Now we define a duration. We create one more object called duration and we assign the movie duration is 1.5 hours approximately. And now we call a function add time. First object is the start of the movie, and second one is the duration of the movie, and we just add these two objects attributes and we get the new object called movie finish time, which is represented with the name done, and finally we print the value done, which represents the movie finish time. What is the problem in this function? Can you observe the problem? This function does not deal the few cases, especially when the number of seconds after addition increases above 60. What happens? Similarly, the minutes upon addition goes above 60. Again, we have not tackled these two complications. And let us improve the version of the first prototype add time by incorporating the solutions to these two complications. When minutes adds up to more than 60, what to do, and similarly for the seconds. So this is the second version enhanced prototype, because we are now dealing with one complication. We are enhancing the existing prototype so as to incorporate the error or a constraint. Again, these three statements remain same of the previous prototype, sum, the first set up to here. And what we have to do is, if seconds after summation goes above 60 or equal to 60, we have to change the attributes minutes and second. We have to increment the minute as well as we have to reassign a seconds as after the remainder after subtraction, the result of the subtraction. Similarly, we have to do the same minutes, something like this. You change the minutes by subtracting 60 and we increment the hour. Now this prototype handles these two complications, and sometimes it is useful for a function to modify the objects as it gets the objects as parameters. In that case, the changes are normally visible to the caller because whatever the changes made in the function are visible outside the function. Let us now develop one more function as the initial prototype to increment the time object, not to add. We want to increment the given time of day with some value, with seconds or minutes or hours. Here we take up only the seconds. We want to increment the time by adding some number representing the seconds. We have a function called now increment. It takes one time object called time and the number seconds. What we have to do here is we have to add these seconds. We add the seconds, and if after addition, if the seconds results above 60 or greater than equal to 60, we modify the seconds attribute as well as we increment the minutes. And same thing we have to do it for the minutes. After addition of this minutes, is there a minutes gets the value above 59, then we reset the minute as well as we increment the hour. If you look at this function, increment is a modifier. It modifies the object parameter time with the new value, and new value is computed based on the second parameter. So increment is a modifier function which adds the given number of seconds to a time objects, and whatever the modifications are now visible to the caller also. Let us analyze this function, whether this function is correct. What happens if seconds is much greater than 60? If parameter itself has value above 60, we have not handled that situation. We have handled the situation only after addition. Only after addition we might get a value more than 120. In that case, let us say the parameter seconds has got 70 and we have something here 55. Definitely addition will go above 120 and we will not get the correct result. So one solution to handle is replace the if statements in the previous function with the while statement, and definitely we get a correct result because we are going to subtract 60s as long as the seconds are greater than equal to 60. But thing is, it is not very efficient because the loop, we are going to execute a loop several times. That is depends on the value of seconds parameter. If it is some 500 or 1000, then loop is executed several number of times. So this is a loop function, you can see, for the seconds. Instead of if, we have replaced with while. As long as time dot second gets a value less than 59, we are going to subtract the seconds and we are going to increment the minutes. And similarly, we can write a function for the minute. We can replace if statement in the for the minutes also with the while time dot minutes greater than equal to 0, time dot minutes minus equal to 60, and time dot hour plus equal to 1. That's how we can modify that program segment. What is the second solution? Second solution is we retain the if statements as it is, but compute the minutes and seconds with the integer division and mod operator. So we can get the minutes by using integer division. The quotient gives me the minutes, and then we can add that minutes directly to the time dot minutes. And second is a remainder after division. So we can use these two operators, the integer division and mod operator. We can even combine also, or we can have a separate two statements wherein we can rewrite this code for the seconds as well as the minutes like this. Let us understand the code for the second. If time dot second is greater than or equal to 60, what we have to do is we take a reminder after division by 60 mod 60. So that becomes the new seconds, and we increment the minutes by this much of value. There is a integer division, is nothing but number of minutes. Same thing can be done for the minutes attribute. If time dot minutes greater than or equal to 60, here we have to write time dot minutes and here time dot hour, and we have to change the attributes accordingly here too. So that's how we can enhance the basic increment function to incorporate these two complications. If the seconds is more than 60, what we are going to do to deal this situation? And we found two solutions, and second one is more efficient because there is no looping. First one is less efficient one. To summarize, the prototype and patch is a program development strategy where the development of code is refined incrementally, stage by stage, by fulfilling the constraints and special cases. And the methodology or the method that is being used in prototype and patch is the writing a function. And how do we write a function? We initially write a simple prototype for the function as a function, and then we test the function, and if any errors are there or any constraints are not satisfied, we refine the prototype through the enhancement, and again we test it till all the errors are patched or all the constraints are incorporated in the function which represents the solution to the subproblem. What are the advantages? One advantage is we can start the program development or application development with a basic understanding of the problem. We don't have to have a deep understanding through requirement analysis. There are limitations as well. Since the code is developed incrementally by handling the errors or constraints, the code is little complex to understand. That means readability is poor because the special cases are added once they are detected. Ultimately, that increases the size of the code as well as the ambiguity in understanding the code. Also, this might result in and inefficient in terms of the solution in terms of the response time. The alternate design strategy for prototype and patch is design development, in which high level analysis of the problem will make the programming much easier and flexible as well as efficient. If you remember, we wrote add time and increment functions. Actually, we were doing the addition in page 60, modulo 60, in which we did that addition for seconds and minutes. And the observations suggest another approach, observations through analysis, that we can convert the time objects into integers and then we can just add integers where computer knows how to do integer arithmetic. How to do it? We can convert a time object into integer by converting these three columns, hours, minutes and seconds, into a single integer representing the seconds. Here is a function that converts the time object to a integer quantity. We define a function time to integer. It takes a time object, and first we take up the hours and we convert that hours into minutes. Then we take up the minutes and the seconds in the time objects as well, and we convert into seconds, and this seconds represents the integer number which is equivalent to the time object time, and ultimately finally we return the seconds. Here is a function which converts the integer to a time. This function takes the argument which is a integer quantity, and also we make use of a divmod built-in function of Python, which divides the first argument by the second argument and returns the quotient and the remainder as a tuple. In this function we create a new time object, and now we apply divmod onto the seconds, which gives me the minutes as a quotient and the remainder is a seconds. This goes to the new object time dot seconds. Next we use this minutes. We apply divmod on minutes now. Divide by 60, that is integer division as well as modulus operator, and we get a tuple time dot hours which are assigned to a new object. Similarly the minutes are assigned to the new object, and finally we return the new time object named time. How to test for correctness? So if we, for any value of x, if this equation is satisfied, it means this function is correct. The time to integer and integer to time, because these two operations are inverse to each other, and ultimately if we apply these two functions in this manner, results in the actual integer x. That's why if you do this consistency check and if the function passes it, it means that the function is right. Once this function is found correct, you can use this function to rewrite this add time with less number of lines of code. Now we have a new function add time with the designed development approach where we analyze the problem of adding it. Instead of doing the modulo 60 for 2 columns of seconds and minutes, we have converted the time objects into seconds, and then we wrote two functions, one to convert time to integer and then a reverse operation, integer to time. With these two operations we can add the two time objects. Here is the first line where we convert the first time object to integer, and then we convert the second time objects into integer, and the seconds representing these t1 and t2 are added and assigned to a variable seconds. And now we convert this second into time object. Again we call a reverse function, this function to convert integer to time, this integer quantity. This returns an object of type a time, which is nothing but the addition of two time objects. These are the review questions on this chapter. Questions are very simple. If you understood this chapter, definitely you will be able to answer these review questions, and also you will be able to execute these simple programs. One is about modifying the print time, and also one more to write one more function called isAfter, where you should not use a if statement. One hint is you can convert the time objects into integer, and then doing any comparison you can return. Okay, that's what the hint to solve this problem, and it's a very simple problem. And finally you can write a function to add a duration to a given time object, and you can call function appropriately. Here is a one link for you for further reading on pure functions and modifiers. Thank you.